All right, today we're going to talk about is probability with and, the multiplication rule. So there's a couple terms that you need to understand before we do this. So you need to understand what an independent event is. So that's when one event does not affect the outcome of the other. So the grade you get on a test and your classmates, so your test and your classmates' test do not depend on one another. A die is rolled and then a coin is tossed. One event does not affect the other. So you can also see the probability of A and B. So the probability of A times the probability of B, or the probability of the intersection of A and B, which would be the probability of A and the probability of B. So this is your little formulas you can use. And then for dependent event, it's when the outcome of one event does affect the outcome of the other. So examples, and then let me just, there it goes. Very important there. All right, so some examples is finishing first or second in your graduating class. So if you finish first, you're not going to finish second or vice versa. Drawing 3 marbles from a jar without replacement. So if you don't replace it, it's going to change the events or how many you have total. So for that one, you have the probability of A and B, which equals probability A times the probability of B after A has happened. So independent, you're just multiplying them together. Dependent, you're multiplying after the event's already happened. All right, so let's first just check a few examples. So the choice of a sandwich and a drink at a restaurant, well, they're independent from each other because a sandwich isn't connected to which drink you order. Drawing 3 marbles from a jar without replacement. So this without replacement is key to making this dependent. The grade you and your classmate earn on the test. Well, your grade and your classmate's grade are not dependent on each other, so that would be independent since you should be doing your work independently. All right, go ahead, try those. And then now let's go ahead and let's start doing some examples. So for this one, the chorus at Lakeford High School sings songs from an old songbook. 5 of the songbooks have red covers, 4 have blue. One student selects a songbook at random from the shelf and then places it back on the shelf. A second student does the same thing. What's the probability that both students looked at the songbook with red covers? Well, this is considered an independent, and it's because they placed it back on the shelf. So since they put it back on the shelf, you have this event does not affect this event. So they both have a chance of 5 out of 9. And so now you're going to multiply them, which will be 25 over 81. And I got 9 because I added the 2 together. I didn't tell you that, but I had it written down. All right, the next event, a bag contains 6 orange, 8 blue, 4 yellow. What's the probability of selecting 2 blue marbles in succession, providing the marble drawn first is then replaced? So since it's replaced, one event is not going to affect the other, so it's independent. All right, so for total, you have your 6, 8, and 4, so you have 18 total. So we have blue here out of 18, and then a blue out of 18. So we have our 2 blues, which would be 64 over 324, and it simplifies to 16 over 81. So those are both independent events because they do not depend on the other. And if you notice, all we did was just multiply the probabilities. All right, so now we're going to get into dependent. So we've got 9 pennies, 7 dimes, 5 nickels, an antique coin collection. Suppose 2 coins are to be selected randomly from a collection without replacing the first one. So now we're going to find the probability of each event. So if we want to know the probability of a penny, well, that's 9 out of 21 total. And then a dime. Well, if we're not replacing the first one, we're still going to have 7 dimes, which is our total. But since we took 1 out from here, instead of 21, we now have 20 left. So we have 21 coins, but we took the penny out. So now we have 20 coins left. So now go ahead and multiply these and you'll get 3/20. So this is a dependent event, and when it's a dependent event, you want to change the amounts. So since you're not replacing it. All right, so now let's look at 2 nickels. So I have 5 nickels out of 21 total. And then now if I pulled a nickel the first time, I have 4 nickels left. And then since I did not replace, instead of 21, I'm now at 20 coins within the collection. So then go ahead and multiply them and you'll get 1 over 21. So your probability is 1 over 21. All right, so now we've got 3 quarters, 4 dimes, 5 nickels, and we've got 3 coins are to be selected without replacement. So this is going to be dependent event, which means that you're going to change your amounts if it's dependent. So if we're selecting 3 quarters, well, I've got 3 quarters and we're doing 3 coins. So the first option, I've got 3 out of 12, because that's the total number of coins we have. But if I don't replace one of those quarters, I'm now left with 2 quarters out of 11. And then if I didn't replace either those 2, now I only have 1 quarter left out of 10. And you multiply, simplify, and you'll get 1 over 220. Now, if we're selecting a quarter, a dime, and then a nickel, if you were without replacement, I have 3 quarters out of 12. Well, if I don't replace that 1 coin, I have 11 coins left. So 4 out of 11. And then same thing, if I don't replace these 2, I have 10 left. And then I have, since I haven't picked any other nickels, I have 5. So go ahead and multiply those and you'll get 1 over 22. All right. So now I want you to try these 2. Now remember, you can look at your previous lesson for the 52 cards to remember what there are. But I want you to go ahead and I want you to determine first, is it dependent or independent? And then go ahead and solve. All right, let's go ahead. Let's do this one. And it says, if 2 cards are selected from a standard deck, the first card is placed back in the deck before the second card's drawn. Find the following probabilities. So in this case, so the probability of a heart and club. Well, the probability of a heart, you could either do 3 out of 52, but truthfully, you know, or 13, excuse me, but you know that's actually 1/4. So we're going to go 1/4 times 1/4, which equals 1/16. So, because there's 13 hearts, 13 clubs, and 13 over 52 equals 1/4. All right. And then since it says and in the middle, we're multiplying. All right. So now we want a red card. Well, a red card is half the deck. So half of 52 and then 4 of spades. So here you need to think about 26 out of 52 cards. And then 4 of spades. Well, you only have 4 spades. So that's going to be, oops, sorry. You only have 1 4 of spades. So it's a 4 of spades. So this is only 1 card. Okay. So now I know 26 out of 52 is actually 1/2. So I'm going to use this as 1/2 times 1 over 52. And I'm going to get 1 over 104. There you go. All right. So now the probability of a spade, well, there's 13 spades. And we all have and the ace of hearts. Well, there's only 1 ace of heart. So that's your only one there. So remember, we just said that 13, I'll put it over here. 13 over 52 is the same as 1/4. So I'm going to do 1/4 times 1 over 52, which will give you 1 over 208. So you can keep the big numbers Or if you already know, hey, I've got 4 groups, or this is 1/4 of the total set, you can use either or, it doesn't matter. All right, and then here, the probability, it's a queen of hearts. Well, you only have 1 queen of hearts and a king. It doesn't specify how many kings or which type of king, so I know I have that. So the probability, and remember, probability you're always going to write as a fraction or a decimal. So probability of queen of hearts, you've got 1 out of 52. Well, with king of hearts, you've got 4 out of 52. You're going to get a really big number, or you could have done 1/13, I guess, but yeah, so that should have been 1/13 from there. All right, so now that's your final, these are all your final answers. So you're going to go through and you're going to do this next one, but the important part here is it's not replaced. So you're going to watch your totals. So just be careful because this one is dependent. And then this up here, I didn't write it, but this is independent because it's placed back. All right, so go ahead and I want you to try those. Oops. And then that is probability with and. Remember, independent, it does not affect the outcome of the other. Dependent, it does affect the outcome of the next.